Okay, so today we are on Unit 3, Lesson 2, Solving Inequalities with Addition and Subtraction. So solving these types of inequalities is very similar to solving one-step equations. So when we're shown an inequality like this, x minus 6 is greater than or equal to negative 10, I am asking you to solve it and graph your solution. So solving an inequality is very similar to solving an equation. We are trying to isolate x, meaning we would need to eliminate negative 6 from that side of the inequality. The way I would eliminate that negative 6 is I would add 6 to both sides because I am undoing that subtraction, okay? So I'm adding 6 to both sides. So my solution looks like this. X is greater than or equal to negative 4, okay? Now, when we were solving equations, that would mean my solution was negative 4. But in inequalities, this means a different thing. So for you to graph this, I'd expect you to draw a number line, and really all I care about is that you have negative 4, and then one number that's less than negative 4, one number that's greater than negative 4, and that's all I really expect for the graphing. So we've got to remember from the last lesson what type of circle we put at negative 4. Since this is greater than or equal to, negative 4 is part of my solutions, so I'm going to draw a colored in circle. As for the shading, however you want to do it is up to you. I am going to shade to the right to represent greater than. So values greater than or equal to negative 4. So that's how you solve and graph a one-step inequality that involves addition. So you can move ahead and work on the guided practice, and I am just going to show my answers so that you can compare them. So this is a good chance to pause the video, try these on your own, and then check your answers with me. Okay, so I'm not going to spend much time explaining these. You can check them on your own. But for number 3, I just wanted to show I added 1/4 to both sides. I got that 1/4 plus 1/4 was 2/4. I simplified that to be 1/2, and then I rewrote my inequality as y is less than 1/2. So when the inequality has the variable on the right, you can just flip everything around to force the variable to be on the left. So this became y is less than 1/2. So I put an open circle and I shaded to the left. So for example 2, solving using subtraction, it's basically the same thing, except you are moving your value to the other side using a different operation. So in part A, y plus 8 is 5. I would isolate y by subtracting 8 from both sides. So this becomes y is less than or equal to negative 3. And then I'm going to graph my solution. Again, 3 numbers on your number line is enough for me to say you know whether to shade left or right. So closed circle at 3, negative 3. And since it's less than, I'm shading to the left. For part B, subtract 1.4 from both sides. And the thing here is, if this 1.4 were negative, I'd be adding 1.4 to both sides. But since it's positive 1.4, I'm subtracting it from both sides because 1.4 minus 1.4 is 0. So this becomes negative 9.4 is less than m. I'm going to rewrite this as m is greater than negative 9.4. I always want that variable to be on the left. That makes things easier to read, which makes things easier to graph. So negative 9.4, for numbers I would pick, maybe I'd go negative 9.5, negative 9.3. A number less, a number greater. This would be an open circle since it's just greater than, and I would shade to the right to finish graphing that solution. Okay, I would shade to the right because it's greater than negative 9.4. So remember to rewrite your inequalities so that the variable is on the left if it isn't already. So guided practice again, pause the video, solve them through, check your solutions. You may want to pause when you check your solutions. If you need further explanation, let me know. I can further explain these to you. Okay, so for the guided practice, again, I'm not going to spend a ton of time explaining them. Take a second to maybe pause and just double check your answers. I'm just going to talk about number 5 really quick. In number 5, I subtracted 1/6 from both sides. 5/6 minus 1/6 is 4/6, which simplifies to 2/3 because I can divide 4 and 6 both by 2 to get 2/3. So I got 2/3 is less than or equal to z. I flip that around to write z is greater than or equal to 2/3. That is the important part. If the inequality doesn't have the variable on the left, force it so that the variable is on the left by flipping everything around. If you flip the inequality around, you have to flip the symbol around. So that's why I have greater than or equal to. I have to flip that symbol around. So I've just got one more example to show you where we're modeling using inequalities, and talks about a circuit overloading at 1800 watts of electricity. You plug a microwave oven that uses 1100 watts of electricity into the circuit. We're going to write and solve an inequality that represents how many watts we can add to the circuit without overloading the circuit. So like if you plug in your toaster to the same circuit, will it overload the circuit? So an inequality I would write, I'm going to define a variable first. My variable, maybe I'll do something like W for watts of a new device. And we want to know how many watts we can add to the circuit. So I have my 1100 watts of my microwave plus however many watts of the device I add to the circuit, and it overloads at 1800. So we know that this total wattage that we're creating has to be less than 1800 because it overloads at 1800, so it can't reach 1800 watts. So if I'm going to solve this inequality, it's a pretty straightforward one. I would subtract 1100 watts from both sides, and I would say my wattage has to be, of my new device, has to be less than 700. If you want to write watts just to keep you keep track of the wattage, that's it. So W is less than 700 watts. I can't add 700 watts to that outlet. I've got to add less than 700 watts. So what we're looking at here is which of these devices can we plug into the circuit at the same time without overloading the circuit. So we've got to find devices that are less than 700 watts. So a clock radio is fine. A blender is fine. They're under 700 watts. A hot plate would not be okay. A toaster, not okay. It might cause a fire. You might just short out the circuit. So the devices that we can plug in would be the clock radio and the blender. The hot plate and the toaster would be too much. It would overload the circuit. So those are the only devices that satisfy our inequality up here, that satisfy this 700 watts, less than 700 watts, okay? So those are the devices that wouldn't work. So now this one says, the microwave oven, a new one, uses 1000 watts. Does this allow us to have the microwave oven and the toaster plugged in at the same time? Now that's a good question. Because we said our new inequality maybe for this is our wattage of our new device plus 1000, and we said that needed to be less than 1800. Well, now I'm saying, oh, sorry, I wrote 100,000, right? So does this allow the microwave and the toaster oven? Well, the toaster oven is 1800, or 800, sorry. Creating 800 plus 1000, that would be 1800. Has to be less than 1800. That's not true. So we would say, no, 1800 watts would, we said before, overload the circuit. And the main reason why is we said it had to be less than. If this were less than or equal to, we'd be okay. But since it's less than, 1800 is not part of that solution. So I'm just adding together the 1000 watts plus the 800 watts. That would overload the circuit because it hits 1800 watts. So right now you guys should be able to move on to the practice. Make sure you're following directions. Make sure you're asking questions if you have them. Hopefully this is a fairly simple practice for you guys. And just make sure that you're ready for the checkpoint before you move on.